Alright, the problem I gave y'all. And then got rid of it. I'll write it down up here. Well, as soon as I hit unfreeze, it's going to go away. So. It's installing the driver. What's the problem?
1 over x minus 1 plus 2x minus 1 over x squared plus 3.
Is that it? Alright, these two have nothing in common. So they have nothing in common, you just multiply them together. So the common denominator here is going to be x minus 1 times x squared plus 3. Plus x squared, x minus 1 times x squared plus 3. And how many times will x minus 1 go into this? X squared plus 3 times. 1 is 1 times x squared plus 3 times. How many times will x squared plus 3 go into this? X minus 1 times this is the FOIL method. So right here is going to give us, and all that's over one denominator. And that's going to give me x squared plus 3. Plus, I'm just going to go over here and put brackets. This will be 2x squared minus x minus 2x is 3x plus 1. Somebody check me. And that's going to give me x squared plus 3 plus 2x squared minus 3x plus 1 all over a squiggly line, which means all that stuff. And what's x squared plus 2x squared? And that takes out the x squareds. The 3's can't move. The minus 3x. And 3 plus 1 is 4 over squiggle line. Huh? I'm sorry. Where did you get the x cubed? Oh, well, I hadn't done the bottom yet. You don't want to do the bottom because you might be able to factor this and cancel something out. So I'm going to leave it alone. I'm going to just wait a minute. I don't know if this is factorable, but let's try it. Well, I can't screw up 3, can I? Can't screw up 3 because there's only 2 multiples of 3, 1 and 3. So you can't screw that up. So let's look at 4. 1 and 4, 2 and 2. Well, 2 is easy to do because it's the same whether you switch them. So let's go ahead and knock that one out and see if it works. 2 here and a 2 there. That'll give you a 2x and a what? 6x. Will 2x and 6x ever give you a 3x? No, so you can forget the 2s, they won't work. I'm not even going to put a 4 there because that's going to give you 7, and that ain't, or 4 times 3 is 12, that ain't going to work. So I'm going to put the 4 here and the 1 here. 4 and 3. Will 4 and 3 ever give you a 3? No. So you can't factor it. So your final answer is 3x squared minus 3x plus 4 over common denominator. And you can change it to x cubed, but that'll just take time, and I would just leave it like this on the bottom, unless it says multiply at the end of the problem or something like that. Now, this is a partial fraction because you've got 2 fractions that have nothing in common. So that's one way of doing it. Here's another partial fraction. Can't hardly read it, but x minus 1 times x squared plus x plus 1 over x minus 1 times, is that the same thing? That can't be right. Let's see what the original was. Maybe I copied the wrong thing now. Not just pull one out of the book. Yeah, let me just get one out of the book because I can't find one that I want without it going into, this one's okay. Look at it. Yeah. No, that's calculus. It's got calculus in it down at the bottom. I don't want to do that yet. I don't want to get you confused before we even get started. Maybe the book has a review. Let me see what it has. There's an example of partial fractions that we just did. We did one like that. But that ain't what I'm looking for. I'm looking for A, B, and C. It's going to take them 3 or 4 pages to... There it is. Right here. So they do go into it a little bit as a refresher. Okay, here's one. Yeah. This one right here. Write this one down. It says evaluate x squared plus 2x minus 1. I'll blow it up for you and snip it. Right there. X squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. And they want you to solve it using partial fractions. First thing I would do is try to factor something out of the denominator if I could. That might help you out a little bit. Whenever you're working with partial fractions, the first thing you need to do is see if the denominator can't go into the numerator. If it can't, then you need to rely on factoring to get you started. There's our problem. First thing you want to do is see if you can divide. Well, you can't, because the degree of the denominator is what? Higher than the degree of the numerator. So you can't do anything. So then you rely on factoring. Well, before we even start this, what can I do to the denominator before we even start? Factor out of x. That'll give us the antiderivative of x squared plus 2x minus 1 over x times 2x squared plus 3x minus 2 dx. So could you dx. And then that's going to give us the antiderivative of x squared plus 2x minus 1 over x, parentheses, close parentheses dx. And that's going to give us 1x and 2x. You can't screw that up. And if I put a 1 and a 2 here, that's going to give me a 4x. But if I flip it, put a 2 here and a 1 here, that'll give me 4 and 1, and that'll give me a 3. But 4 has to be what? Positives, and the negative 2 is unlike, so now we're ready to use partial fractions. Partial fractions is where you have a over denominator plus b over denominator plus c over denominator. Now, why aren't I using x squareds or anything like that? Because these are all to the what? They're all to the first degree. So you're going to set up 3 fractions over here. What disconnected?
And move to the right, move to the block.
What's wrong? You got it. What'd you say?
The board doesn't want to.
Yeah, tell me about it. Did y'all see that? Okay, it did. Fine. So that's going to give us the antiderivative of A over X plus the antiderivative of B over X plus 2 plus the antiderivative of C over 2x minus 1. Now what you want to do now is basically you've got this. Let me take this out because this is more of an equal sign more than a yield sign. So you want to clear the denominator. What do you have to do to clear the denominator? Multiply both sides by what? The common denominator, right? So multiply this side by this. Multiply this side by this. Go ahead and do that. Y'all remember how to do partial fraction? A lot of people don't. So don't take it to heart. Doesn't mean you're a failure or anything. It just means that you're probably going to live in a ditch. So multiply both sides by x times x plus 2 times 2x minus 1, and of course these go out, and you're left with x squared plus 2x minus 1 is equal to, now right now I'm just ignoring the calculus and I'm just doing the algebra because we gotta find out what A, B, and C are. So we're just doing algebra right now. So is equal to A, what's missing here that's in here? The two binomials, right? So we gotta multiply that by A, that'd be x plus 2 times 2x minus 1. What's missing here? X and what else? 2x minus 1. Plus C. And what's missing here? The x right here and the x plus 2. So x squared plus 2x minus 1 is equal to A and that's going to give you 2x squared, I'm seeing if anything cancels out, plus the minus 2x plus 4x would be 3x. I think we've already got that up here somewhere. We'll just leave it for right now. I'm looking to see if we can maybe pull some x's out. Well, let's just go ahead and see what happens. I'm trying to see this bx and this cx can go together, but you can't do anything else. 2x, no. Go ahead and do the algebra here if you want to. You don't have to do the algebra here. There's two ways you can go here to solve it, to finish it out. You can go mathematically and say what will give you a 0. Let's see, 2x plus 2x minus 1 equals 0, be 1, and divided by 2. So we could let x equal 1/2, and that'll knock out 2 of them, won't it? Somebody tell me if I'm doing my math right. 1/2. What's 1 minus 1? 0. So this first 2 will go out. Trying to give you a couple of hints. So that A is going to be multiplied, what does this come out to be? 2x squared minus x plus 4x minus 2. And this right here is going to be plus bx, and I'm just, let's see, bx times 2 would be 2bx squared minus what? Bx. And then what is this? Cx squared plus 2c. And then we need to simplify what? I got 2c down there. 2cx. 2cx, is that what you're talking about? And then we gotta condense this down, so we've got, maybe we can get the last one, take over to the other page. X squared plus 2x minus 1 is equal to a times 2x squared plus 3x minus 2 plus 2bx squared minus bx plus cx squared plus 2cx. I don't even know why I'm trying this. I know it won't work. Alright, now we got to combine like terms. We got to distribute this thing across. So x squared plus 2x minus 1 is equal to 2ax squared plus 3ax minus 2a plus 2bx squared minus bx plus cx squared plus 2cx. X squared plus 2x minus 1 is equal to 2ax squared plus 2bx squared plus cx squared plus 3ax minus, is that a bx right there? Like, minus bx, minus 1bx plus 2cx, is that it?
Yeah.
There's supposed to be one more thing. Minus 2a? X squared plus 2x minus 1 is equal to 2a plus 2b times what? X squared plus no, let's see right here. I'm sorry, I missed one. There, how's that? Is that better? 2a. It's 2b. Let's see. I factored out the x squared and put it on the right instead of putting it out front. Plus 3a minus b plus 2c times x. Minus 2a. So 1 is equal to 2a plus 2b plus c and 2 is equal to 3a minus 1b plus 2c. And then that -1 is equal to what? -1 is equal to -2a. But I'm not going to worry about that. We don't have to have that because that's two equations, how many unknowns? So you're going to have to use this spot right here. This 2a, this is one spot, minus ax squared plus bx plus what? C. Ax squared plus bx plus what? C. So -1 is going to be equal to -2a. System of equations, yes. So -1 is equal to -2a. All right, knock yourself out. I'll do a for you. I'll find a. I'll do that for you. Huh? Okay, I'll give you A. A is equal to 1/2. I did that one for you. So what are you going to do with that A is equal to 1/2? Plug it in, so now you'll have 2 equations and how many unknowns? 2. And now you can solve it. And you feel good about yourself. Yep.
Will that be the final product?
No, we haven't even done the calculus yet. We just review it over partial fractions. Yeah, I've got 2 or 3 problems to review before we even get to taking the derivative. I mean the antiderivative. But actually, they don't do a lot of integration in this section. It's mostly just taking mostly it's finding the solution by using partial fractions. I think that's what we'll have to look at in the book. Some of y'all still have 5 days grandmothers. You about to what? It's amazing how many grandmothers you'll have. Okay. They can still die too, right? Yeah. They can still be used as an excuse. I just lost my pen. There it is. I found it. Okay, since I did that hard part for you, A is equal to 1, we're going to take this over to the next page. And it's going to copy half the page, but that's okay. Like we wasn't expecting it to do something weird. I watched Ron Rash's second movie, Serena. Yeah. It's got what's her name in it? Dang old. What's her name? Mockingjay. Hang over. Yeah, but what's the character? Yeah. And Brad Cooper. It was a good movie. It was better than the first one. Huh? Serena by Ron Rash. It used to teach here. Yeah. And I'm in his books. Yeah. In Serena, I'm McClure Mountain and McClure Campground. And in Saints at the River, I'm a deputy sheriff. And in the first one, with 1 foot in Eden, I'm the sheriff, but he don't use my name. He just says former Marine that went to Clemson and likes to beat up on hippies. And in the third novel, I'm a former Marine that come back from one of the wars, I can't remember, and it was Vietnam or anyway. And my name's Hubert Toomey, and I've got a peace symbol on my necklace. I've got a necklace, and I'm a dope smoking hippie, and I'm wearing a peace symbol. Yeah. He did that just to aggravate me. And my great-great-great-grandfather, Hubert Toomey's great-great-great-grandfather, that was in the war between the states, he was an officer, and his name was Hubert Chambly McClure. He was my first English teacher in college.
So
Here at Tri-County Tech.
Your great-great-great-great-great-grandson.
No, not if I can help it. I'll come back and haunt his butt. He ain't gonna be no pothead. Try to get me one of those, like on Ghost, get my energy up to where I can get a gun and shoot him. Rather he be dead than a pothead. He taught here, let's see, I started in 94, 95. About 2005, 2006, that's when he left. And the only reason he left is because it was a pissing contest between him and the department head. They just wanted, Tri-County Tech wanted him to keep writing books, and they were going to pay him to write books, but so take this one, and that's going to be A is equal to 1/2. BS your way back through it. So 1 is equal to 2 times 1/2 plus 2B plus C. What? What'd you say? Now I thought we shared everything. You're not going to share. Whatever. To be or not to be? That is the question. For the evil that men bring upon themselves and they die. 2 is equal to 3 times 1/2 minus 1B plus 2C. And that's going to come out to be 1, and that 1's going to make this to be what? 0 is equal to 2B plus C. And this is going to be 3 halves, and this is 4 halves. 4 halves minus 3 halves is 1/2. So 1/2 is equal to negative 1B plus 2C. Well, we got opposite signs right here, so I'm going to multiply this guy by what? I'm going to multiply by 2, so I can get a negative 2 right here. So 0 equals 2B plus C, and this one, what's 2 times 1/2? What's 2 times negative 1B? What's 2 times 2C? And what happens to the b's? Cancel. And you get 1 is equal to 5C. Therefore, C is equal to what? 1/5. So A is equal to 1/2, huh? Did I do something wrong?
No, that's
Okay. So A is equal to 1/2, B is equal to 1/5. So now I can back substitute, and I could probably plug that into this one. So 1/2, I'm going to do it in blue so you know it's different. 1/2 is equal to negative B plus 2 times what? 1/5. And 2/5 is the same as 4/10. I'm thinking out loud. So, so 4/10 would be easier. Well, we could do fifths. Negative 2/5 over here. Negative 2/5 plus, so 10 here, and 10 here, plus and minus, 5 will go in there, it'll be 4, 2 will go in there, 5. I got 1/10, negative 1/10. Is that what y'all got? So A is equal to, I don't forgot what we're looking, oh, we're looking at A, B, and C. So A is equal to 1/2, huh? It should be negative because there's a negative B right here. So A is equal to 1/2, B is equal to 1/5, no, B is equal to negative 1/10, and C is equal to 1/5. Now we need to take that information you'll just write it down and give it to me on the previous pages, because I'm not going to try to, I'm not going to do that. So 1/2, negative 1/10 to 1/5. Huh? Yeah, I could, but I don't feel like doing that. And we could put that in here, so I'm just going to take this guy, and it's not done. So copy, and paste, and let's move that over to here. All right, somebody give me A, B, and C now. 1/2 over X plus negative 1/10 over X plus 2 plus 1/5 over 2X plus 1. Now, I didn't say go ahead and solve it in one step. I just said write down A, B, and C. Because I know somebody's saying, well, why don't you go ahead and go? Just do it step by step and quit trying to be a rocket scientist. All right, so the 1/2 comes out. So that'd be 1/2 antiderivative of dx over x. That looks familiar. Plus or minus 1/10 dx over x plus 2 plus 1/5 of dx over 2x plus 1. Now take a minute. Now you need to apply your calculus. Huh? I think the first one is du over u. And that's what I was thinking. I don't even think they did I don't even think did they do it in the book? Where's the book? I don't think they did they? Oh, it goes on to the next page. I think it's right in here, yeah. So it's kind of hard to mess this one up, isn't it? Not all the time. Now you got to be careful with that 2x right there. Why? Because in order for you to take the derivative, that's got to be 2 dx up here, so you got to add a 2 inside, and you got to add a what? 1/2 outside, and that'll make it 1/10. So that's your mistake right there. That's where you're going to screw up on the test right there. Of course, y'all not, because y'all perfect, right?
Yeah.
No, we'll miss it.
Plus k.
How is it plus K?
It's got to be plus k here because we've got different variables here. Even though it's the same.
Put a Greek letter over there.
You can't use anything with k if you do it's wrong.
No, it can't work.
No, you can't use lowercase either because that wouldn't. Remember, I'm trying to get you to fail the class, not pass it. No. Equals 1/2. No. Equals 1/2. Dang old natural log of what? X minus 1/10 natural log of x plus 2 plus 1/2 times 1/5 is what? 1/10 natural log of 2x plus 1. You could put plus c if you wanted to, but since it is partial fractions, some people put k, but I'm not on here. All my examples and all their examples are partial fractions. Okay, they did do the calculus. Okay, I wanted to make sure. All right, I've got a couple of examples in my book, in my notebook here. We're going to do those now. I've got several examples. Let's do another one like this one. What? What time is it? Yeah. We got 30 minutes.
That's an hour on that.
This one's short.
Yeah, you say that.
You know what I'm saying?
Something long.
Let's see if we can do this one. I'll pick out the short one so we can get 3 or 4 more in. So y'all can do homework tonight. Okay, antiderivative x squared minus 1 over x cubed plus x. Alright, take off. I'll give you all a couple of minutes not to take off this. Now this one you're going to have to add bx plus c in the second term because you've got a square on the bottom. Got to drop 1 degree. Now, first thing you want to do is factor out the denominator. Now we're going to have to use partial fractions to the a over x. So we can say x squared minus 1 over x times x squared plus 1 is equal to a over x plus bx plus c over x squared plus 1. This is x to the 0, this is x to the, this is x to the first power, this is x to the 0 power. This is x squared, this has got to be what? X to the first, so it's dropping 1. Multiply through by the common denominator. Or since you got to do all that work, you could just quit. X squared minus 1. What's missing here that's over here? Well, x squared plus 1 times a. And what's missing here? That's over here. X times what? X times bx plus c. X squared plus 0x minus 1 is equal to a x squared plus a plus b x squared plus cx. So x squared plus 0x minus 1 is equal to a x squared plus b x squared plus cx plus a. And if you're wondering why I put the a here and not here, it's because this is the second degree, this is the what? First degree, and this is the what? 0 degree. Descending order. Don't try to make this complicated. So x squared plus 0x minus 1 is equal to a plus b times what? X squared plus cx plus a. Therefore, 1 is equal to a plus b. 0 is equal to what? C. And negative 1 is equal to what? A. So all we got to do is take that negative 1, plug it in here, and B is equal to what? Now you go back to your handy dandy problem. Right here. Huh? Well, dang. I failed. I have failed as an instructor. Because you're not supposed to understand it, you're supposed to be confused. So I haven't done my job very well. So, what is A? A is -1, right? And B is equal to 2. And C is equal to 0, so it just falls off. What? Yep, it goes to live in the ditch. And now we copy that and take it to the next page. And now we can put our calculus back in the problem. And that's going to be the antiderivative of -1 over x dx plus the antiderivative of 2x over x squared plus 1 dx. And that's going to give me -1 absolute value of dx over x plus 2 antiderivative of dx over x squared plus 1, 2x dx. We got a problem here. This is natural log, so that's going to be -1 times the natural log of x plus 2. And what's the problem here? Where is that? 2 out here. Okay, now we got it. Okay, good. Alright, so 2x dx, so we need a 2 here and a what? 1/2 there, so that takes care of the 2. What? Just leave me alone. Just go away. Go away. Alright, so now we've got du over u, which is what? Natural log of, dang old x squared plus 1. You don't need that to the value on this, but
Plus capital K.
oh, I'm sorry. Don't forget to add your C or K.
capital K. 14
So let's go to your handy dandy homework. And since y'all know how to do this, we'll pile it on. I'll put about 50 problems on there. You're welcome. What section is this? Somebody tell me. Oh, 7 point what? Okay, 7.4. 7.4. I heard that was an awful class. A lot of drawing. 3D drawing. You got to learn how to draw in 3D. 7.4, this is called partial. What? What y'all talking about? Well, CAD's good, but you're not going to be able to use it and you're going to have to draw it on by hand, on the fly. You can't, oh, I'm going to do this problem. No, you can't do that because you're going to be doing it by hand. I'm just telling you. Don't get mad at me. I'm just telling you. Let's see. There we go. You gonna complain? Okay, I'll add 18 more problems. I'm not gonna do that to you. Ooh. No, I don't think so. Let me do that one. That one right there. That one's gonna take more than 6 minutes. Because you've got to factor this. Well, you can do it by U substitution. X squared, yeah. Yeah, I didn't see that. So, yeah, we can give you that one.
Oh, dude.
What?
That one's gonna take forever.
Which
Oh,
one?
okay, we can do that.
No. This is, where is it? Disappeared, didn't it? Oh, we're on the next page.
Yeah, I think today's my homework day.
Alright, today's the what, 31st, 30th? What is it, 31st?
Yeah.
Okay, everything's due next week pretty much. So we'll make this one due next week too. Yep. Well, you already got 7.2 and 7.3 done, so it shouldn't be a problem. Unless you just put it off to the last minute. And your inability to plan does not constitute as an emergency.